Hello guys, this is 11.6 conic sections. So many of you should have seen something like this before, maybe in pre-calc or maybe in high school or in any trig class. So the section on conic sections is basically we are looking at different shapes that is formed by taking the intersection of a plane and like an upside down cone like this, right? Or an hourglass. So by taking the intersection of the plane on the cone like this, we get a circle, right? So you see that we have the circle, and then depending on how you angle your plane, you get different shapes, right? So in this section, what we're going to focus on is ellipse, parabola, and hyperbola, right? And we're actually going to start with parabola now. Okay, so let's look at the definition of a parabola first. All right. So let's look at the definition first. A set that consists of all the points in the plane equidistant from a fixed given point and a given fixed line in the plane is a parabola. The fixed point is the focus of the parabola and the fixed line is the directrix. All right. So on the right, we can see that the focus point is right here, capital F, right? And then the directrix is on the other side of the graph, which is right here. It's the pink line, right? That is called the directrix. So what this is saying is you pick any point on the parabola, right? And the distance between the point and the focus, that's called that A. Let's call this distance A. And the distance between the point and the directrix, right? The shortest distance between the point and the directrix, let's call that B. A is equal to B, right? That's what it means by equidistance or equidistant, right? Any point on the parabola will have this property, right? You can pick any point. Let's say if I pick another point on the graph, let's say this one, right? Then this distance is the same as this distance, right? So that is true for all the point on the parabola, right? And so the two main, well, I should say the three main points on a parabola is first the focus. Let me highlight it. Right, we have the focus, we have the directrix, and then we have the vertex, right, which is either the lowest point or the highest point of the parabola. Right. Now, the standard form of a parabola is right here. X squared is equal to 4py. Now we will get into more details on the standard form in a second. But notice that in the picture, it also tells you how to find the directrix and how to find the point, the focus point, right? And we'll talk about that. We'll talk about everything in details in a second. But this is basically what a parabola is, right? Very similar to what we have seen in like algebra, right? But we didn't go into details about focus and directrix in algebra. We only learned about vertex, right? Okay, so next, let's look at some variation, right? Now we know for parabola, the ones that we are used to are probably like this, right? Right, you either open up or open down, right? So we call these the vertical parabolas, right? And for the vertical parabolas, they have the general form, as we mentioned here, x squared is equal to 4py. Okay. And the value of p will determine whether it opens up or down, right? So in this case, p is greater than 0 and opening down when p is less than 0. Okay. Just like in algebra, right? You look at the coefficient of x squared to see whether it opens up or down, right? Now, in a different sense, we can also have parabola that opens sideways, right? Like this. Right? Like opening to the right or to the left. All right, and that's going to be a little different in terms of journal form, right? But these are called the horizontal parabolas, okay? Because they open sideways. And the general form for this is y squared equals to 4px, right? And just like the same thing, right? If it's open to the right, then p is positive. If it's open to the left, then p is negative. Okay? And let me show you a quick picture to go with that. Okay, so we have two parabola here opening sideways, right? The one that's opening to the right, and then the one that's opening to the left. So notice that directrix, the formula for directrix is actually pretty easy. It's just x equal to p, or x equal to negative p, depending on which one you're looking at. Right? And then you also have the focus. You also have the vertex on these two graphs. And they're fairly easy to find in terms of the calculation, right? And as we'll see later in an example, I'll show you how to find everything. All right, let's look at our first example. The first thing is we want to determine which type of parabola this is. Is it horizontal or is it vertical? All right, so we see y square, which is going to denote that this is going to be a horizontal parabola. Okay, and determine whether it opens to the left or right, we need to figure out p. We need to find p. Okay, so we know that the general form, standard form, is y squared equal to 4px. All right, so in this case, we can say that 4p is equal to 10. That means p is 10 over 4, which is just 5 over 2. And that's positive, right? So a positive p means we have a parabola that's opening to the right like that, right? With vertex at 0, 0. Notice that all the parabola that we looked at, we have focus at 0, 0. We're not considering any horizontal or vertical shift. Okay, so vertex is 0, 0, right? And our goal is to find the focus and the directrix of the parabola, right? So the focus is always inside of the parabola, and then the directrix is the vertical line that's outside of the parabola. Okay, all right. So let's go up. Focus is going to have the coordinate p0. All right, so focus is going to be p0, which is 5/2 and 0. Right, so this point has 5/2 and 0 coordinate, and the directrix is going to have it's going to be the vertical line with x equal to negative p, which means x is equal to negative 5 over 2. And that's going to be your directrix, right? Negative p. So p, the constant p, is the most important value in terms of the parabola, right? Because it tells us about where the focus is and where the directrix is. Okay? And it's similar for vertical parabolas, right? You just need to determine which ways it opens, and then that will tell you about the focus and the directrix. Okay, so that's it for parabola. Nothing too tricky on this. Okay, so next, let's look at ellipse. All right, let's start with the definition of an ellipse. Is the set of points in a plane whose distance from two fixed points in the plane have a constant sum. The two fixed points are the foci of the ellipse, right? So we have two focus points on the ellipse. The line through the foci in an ellipse is called the ellipse's focal axis, right? So right here, this red line is your focal axis. The point on the axis between halfway between the foci is the center, right? It's just like a circle, we have the center point. The points where the focal axis and ellipse cross are the ellipse's vertices, right? So we have the vertex on the two ends of the focal axis intersecting the actual graph, right? So these two are the vertex. So on the line, on the focal axis, you have 5 important points, right? You have 2 vertices, 2 foci, and 1 center. Right? And let's look at how this definition is saying. Right? So you can pick any point on the graph, let's say this point, right? And then you connect them to the 2 focus points. Right? Let's say this is A and B. Right? And then if you pick another point, let's say right here, right? And then you connect this point to the 2 foci as well. Let's call that C and D. So what this is saying is A plus B is equal to C plus D. That's what makes up an ellipse. Right? Any point on the ellipse, if you figure out the distance between that point and the 2 foci and you add them together, they will always be the same. Right? So that's the property of ellipse. And actually another interesting property is if you bring in the focus to the center, the ellipse will look more and more like a circle. And as soon as the 2 foci overlaps with center, you will get a full circle, right? So instead of 2 foci, you only have 1, and that's the center of the circle. Okay, so let's look at the general form of an ellipse. So let's start with an example first. All right, so here are some standard form equations for ellipse, center at the origin. All right, foci on the x-axis is in this form. So the part you want to focus on is a denominator, right? The a square and b square. Whichever has the higher value is going to be the main focal axis, right? For example, in this case, a is greater than b, right? So the denominator of x squared is greater, so your ellipse will look horizontal. Whereas if you have larger value under y squared, which is in the second case, right here, right? A squared is in the denominator of y, where a is greater than b. Then the ellipse, in this case, will look vertical like that, right? So a potato versus an egg. So you need to determine just by looking at the denominator of the equation to determine which type of ellipse you're working with, right? And then the center to focus distance, that's the same formula, right? Foci, right? Foci you need to be careful with, right? If it's horizontal, then the foci are going to be on the x-axis. So this is on x-axis, same as the vertices. And then for the y, they're going to be on y-axis. So in each case, A is the semi-major axis and B is the semi-minor axis. We'll talk about that in a second. All right. So let's give a rough sketch. Let's say this is my ellipse. All right. Okay, that's really bad, but that's okay. So on the longer side, right, so we can see that this ellipse is horizontal. It's longer on the horizontal direction and shorter on the vertical direction, right? So the horizontal direction, that will be your semi-major axis, right? And then the vertical one will be your semi-minor axis. All right, so in this case, we will have the form x squared over a squared plus y squared over b squared is equal to 1. Right? And then the values of a and b are very nice in this case. It tells us where the vertex is, right? That's going to be a, That's going to be negative A, and that's going to be B, and that's going to be negative B. Maybe I should be a little more specific, right? That's A0, negative A0, 0B, and 0, negative B. Right, so the denominator of x squared and y squared tells you where the vertices are. Right, and also have foci, right? Foci, which focus point, which can be found by taking the square root of a squared minus b squared. Okay, so maybe let's say around here, right? C0 and negative C0. And it's similar for vertical. Right? So let's take a look at one example together. Want to find foci, center, and vertices of x squared over 16 plus y squared over 9 is equal to 1. Okay. All right, so first things first, we want to determine whether this is a horizontal or vertical ellipse, right? So we look at the denominator, right? So the denominator of x squared is greater, right? So that means it's going to be a horizontal ellipse like that, right? So a squared is 16, b squared is 9. That means a is 3 and a is 4 and b is 3. Now, of course, we have to include the plus or minus, but we'll take care of that later. All right. So first things first, we know that the center is always 0, 0, right? Not doing any shifting. All right, and we can find the vertices first, right? Vertices. Since it's horizontal, it's going to be a plus or minus A0, so it's going to be 4, 0, and negative 4, 0. Right, and then on the semi-minor axis, the shorter part is going to be 3, 0, 3, and 0, negative 3, but we'll take care of that later. And next, we want to find the focus point, right? To find the foci, we need to figure out the center to focus distance, right? Center to focus distance, which can be found by using the formula C is equal to a squared minus b squared. Right? C is equal to square root of a squared minus b squared, which is equal to 16 minus 9. That is square root of 7. Right? Well, we're just going to use square root of 7 to denote that. Right? So our foci will be radical 7 distance away from the center, right, to the right and left, right? So we'll have radical 7 and 0, and then negative radical 7 and 0. All right, so we have most of our points ready, right, starting with the center, vertices, and foci. Okay, let's go ahead and graph it. So 0, 0, not to worry about that. Let's do vertices first, right? So 1, 2, 3, 4, negative 1, 2, 3, 4. Right? These are the vertices on our semi-major axis. And on our semi-minor, we look at the value of B, right, which is 3, so plus or minus 3. That will be our vertices on the semi-minor axis. Okay, and actually just using these 4 points, you can finish the ellipse like that. And again, I'm not the best at drawing pictures. All right, there you go. Okay, and then label the focus point, right? Radical 7, so that's 2 point something. Let's say right here, right? So 7 and 0, right here. Radical 7 and negative radical 7 and 0. Okay, and center at 0. Okay, that's fine. And that's about it, right? These are label our vertices. And 0, -3. Okay, so that's about it, right? We have all the points on our ellipse. And to show you a better picture, this is what we have, right? So by looking at the denominator of x squared and y squared, that helps us determine which direction the ellipse is going to be, right? Which axis is going to be our focal axis, right? Or the semi-major axis, or the longer part, right? Does it go horizontally or does it go vertically? All right. All right, the next conic section we're going to look at is the hyperbola. Right, let's look at the definition. Hyperbola is the set of points in the plane whose distance from two fixed points in the plane has a constant distance. The two fixed points are the foci of the parabola, right? So very similar to an ellipse, right, where we have two focus points. The line through the foci of the hyperbola is the focal axis, right? So the horizontal red line here. The point on the axis halfway between the foci is the hyperbola center, and the points where the focal axis and the hyperbola cross are the vertices. Right, so very similar to ellipse, right? Instead of a complete circle, right, or ellipse, we have two parabola that's opening to the other side, right? So um, it's the equation is also very similar to the um, to the ellipse. Right, so let's take a look at what the definition is saying here. All right, so let's say we pick a point, right, on the parabola. Then the difference between the distance to the foci, they're always going to be different, right? So let's say this is A, this is B, and then we pick another point, let's say here, right? Like that, and this is C, this is D, right? So the difference between the distance to the two focal points, A minus B, is going to be the same as C minus D, right? Which is just a property of hyperbola, right? Different than ellipse, right? Ellipse is when you add them up, you will get the same thing, right? But for hyperbola is when you're subtracting and you get different things. Okay, so let's look at some of the formulas here, or the form of hyperbola. Okay. All right, so standard form for hyperbola, foci on the x-axis, so it will open horizontally for the first one, and foci on the y-axis, which will be opening vertically like that. And you can see that the main difference between this and ellipse is it's minus, right? It's not add, it's not plus, right? It's minus. Right, center to focus, also different, right? Instead of subtracting, we are now adding, right? Foci is pretty much the same, vertices is pretty much the same. Right, in this case, we don't have the semi-minor axis, right? We don't have to worry about the semi-minor axis. Asymptotes, x squared over a squared minus y squared over b squared is equal to 0, or y is equal to plus or minus b over a x. So we'll talk about that when we look at an example. And the idea is we can actually draw dashed lines, slanted asymptote in a sense, on the graph like that, to show that the hyperbola actually it's growing towards a certain function or a certain line. Okay, so we'll do all that in a second. And so basically that's all the formula you need. Let's take a look at an example. Okay. Let's say I want to graph example 3. X squared over 4 minus y squared over 5. Oops, y squared over 5 is equal to 1. right? And we want to find foci vertices and asymptotes. Okay. All right, let's see. So first, a squared is 4, b squared is 5. Now, in the form of hyperbola, whichever comes first, right, x or y, that determines whether you open horizontal or vertically, right? So here we have x squared minus y squared, which follows the form of the first one, foci on the x-axis, right? So this hyperbola is going to be opening sideways, right, with a equal to 2, and then b is radical 5. All right, so let's first start with the center to focus distance, right? That's the part we need to find, to find the focus. Okay, so center to focus distance, C is equal to the square root of a squared plus b squared, which is 4 plus 5. That is a square root of 9, which is 3, right? And then the foci will just be plus or minus c and 0, which will be 3, 0, and negative 3, 0. Okay. All right, next, the vertices. Right? Vertices is just plus or minus a0, right, on the x-axis, right here, which would be a is 2, right? So we have 2, 0, negative 2, 0. Right, now notice that this is a little different than ellipse, right? The vertices are actually within the foci. Okay, and the last one, we want the asymptotes. Right, the asymptotes here, y is equal to plus or minus b over ax. Y is equal to plus or minus b over ax, which would be y is equal to plus or minus radical 5 over 2x, which is just a linear equation, right? That's linear. All right. Now, for this one, is actually pretty hard to graph by hand. So I'm going to show you a nicer picture from the textbook. Here we go. Okay. So we have the foci at negative 3, 0 and 3, 0, which is inside the parabola, each parabola of the hyperbola. And then we have the vertices at 2 and negative 2. And you see these two red dashed lines, they are our asymptotes, right? So these are the two lines that our parabola has to be bounded by, right? They can never cross these dashed lines. So that kind of gives you an idea how wide or how narrow your parabola is going to be. And that's determined by the asymptotes here in this case. Okay. All right. So basically everything you need is in this table of formulas. But we're also going to try out some other fun example. All right. Lastly, let's look at example 4. Show that this equation x squared minus 4y squared plus 2x plus 8y minus 7 equal to 0 represent a hyperbola. Now, this is a common type of question from this section. They will give you an equation and ask you to confirm or ask you to check what type of conic section does this equation represent, right? And the idea is we want to perform a complete square on this, and then see which standard form that your resulting equation falls into. All right, so let's go ahead and do that. I'm gonna start by grouping the same variables together, right? And then minus 4 y squared minus 2y, and then is equal to 7, right? So I'm doing is I'm grouping the x's together and the y's together and move the minus 7 to the right. All right, so to complete the square for x, I need to add 1, right? And for the y squared minus 2y, I also need to add 1. Actually, let me not do that yet. So when I add a 1 to complete the x square for x, I also need to add a 1 on the right. And here for y, I'm going to add a 1 as well. But when I add a 1 here inside the parentheses, we also need to multiply by the -4. So in fact, I'm actually subtracting 4 in this parentheses. So if I subtracted 4 on the left, I also need to subtract 4 on the right. Okay. And next, we can complete the square. Right? This is going to be x squared plus 1 minus 4 y minus 1 square, forgot the square, is equal to 4. Okay. Now, to show that this is a hyperbola, I need to make this 4 1. So I'm going to divide by 4, right, on both sides. Right, so I'll have x squared plus x plus 1 square over 4 minus y minus 1 square is equal to 1. Right, now that's a hyperbola, right? And since x squared is the first part, this is going to be a horizontal like that, with a squared equal to 4 and b squared is equal to 1. That means a is 2 and b is 1. Okay, so let's start by looking for center to foci distance, which is c equals to square root of 2 square plus 1 square, which is just the square root of 5. Right? And that will be the distance from our center to foci. But our center is not 0, 0 anymore, right? Center, let's actually look at this. Center is going to be -1 and 1. Okay. And it's horizontal. So our foci will be -1 plus rad 5, 1, and -1 minus rad 5, comma 1. Okay. Because our center is on -1, 1. And to move from center to our focus point, we need to move to the right or left by radical 5. And this is what we have. Right? And also, we need the vertices. Okay. All right, so vertices is going to be 2 units to the left or right from the center. Right? So that will be -3, 1, and 1, 1. Like that. Okay, and we also need the asymptotes. Okay, asymptote also has the same formula, plus or minus b over ax. Right, which will be plus or minus b over a, that's 1/2 x. Okay. All right. So that's basically what we have, but even though the question doesn't ask us to graph it, I'm gonna attempt to graph this thing. Okay, so starting with the center. Center is at -1, 1, -1, 1. Okay, and the vertices, -3, 1, and 1, 1. Okay, so vertices. Okay, that's where our points is going to cross. Okay, and foci, -1 plus radical 5. So radical 5 is 2 point something. So it's going to be 1 point something. Just say it's about here and here. All right, the 2 foci in blue. Okay, in asymptotes, it's going to be plus or minus 1/2 x. Right, but center at -1, 1. So we're gonna use this as a center and graph a line that's plus 1/2 x. So that will be like that. Okay, that'll be your asymptotes. And then to complete the graph, you just start with the vertices and graph parabola in each direction within the asymptotes. Okay, again, not the best graph, but something like that. That's really bad, but it's gonna look like something like this. Okay. All right. So the important part is how do you find, knowing how to find different points, right? The center, the foci, and the vertices, as well as the asymptotes. Okay. Um, Probably not too much graphing in this case. But it's more of them is going to be like solving equations, understanding the graph. Okay. All right. And that's it for conic sections. Thank you very much. See you next time.